Hello, my name is Kathleen Carpenter, and today's presentation is being recorded for the Warren County Educational Service Center and focuses on analyzing the PARCC performance level descriptors for high school mathematics. After you view this presentation, if you have any questions, I would encourage you to email me at the address listed on the screen. In order to fully participate in this webinar, you will need, first of all, familiarity with the Common Core State Standards for Mathematics. If you do not have that document, I would recommend that you go to corestandards.org and download the mathematics standards. In addition, I'll also be referencing the PARCC assessment blueprints and evidence tables. I'm going to go ahead and click on that link so that you can see how to get to those documents. When you click on that link, this is the web page that will come up. And PARCC has gone through a kind of multi-level development process with their assessment development. And one document I'll be referencing today are called the Assessment Blueprints and Test Specifications. They've provided evidence tables that describe the knowledge and skills that items will require students to demonstrate. It's a little bit different than what we're going to look at today, but I will be referencing them. So when you get to this web page and you scroll down, you want to go past the language arts and past the elementary and middle school mathematics tables, and you'll get to the evidence table. There'll be a mathematics evidence table for Algebra 1 end of year assessment, as well as for geometry and Algebra 2, and an evidence table for the performance-based assessment and the mid-year assessment. And as we go through today's session, I'll be referencing those. So if you do not have the assessment blueprints downloaded, you might want to hit pause on this presentation and get those documents. The main focus of today's presentation will be analyzing and looking at the PARCC performance level descriptors for Algebra 1, Geometry, and Algebra 2. The link is listed there at the bottom of the screen, and especially with this document, if you do not have this document, you want to hit pause on this presentation and go to that web page and download those three pieces of information. I'm going to highlight that document and point out some main points, and if you have it in front of you, you will want to you'll get more out of the session because you can make some notes on it. As well as you're going to use this quite a bit, not just for this session. So as PARCC went through this development process and looked at the performance level descriptors, this is an effort to very clearly define exactly what content students will have to demonstrate to perform at different levels. And we're going to look at the subclaim A to start with. There are 5 subclaims. And the first one deals with the major content of the course. So as you look at the topical areas for subclaim A, regardless of what course we're talking about, what you want to think about is that this should be the content that takes up a good portion of your time in your course and that you really assess for student understanding. The other item of note is that you'll also see connections to the standards for mathematical practice that are interwoven with the content standards for subclaim A. So let's look at some highlights from each of the 3 end-of-course tests for subclaim A. Before we get into some of the specifics of this table, I want to take you through the format of the table to help you get a better understanding of what information is in it. So let me pull up my highlighter so I can circle some things. As you go through each of the subclaim areas for each of the end-of-course tests, you'll see, first of all, these performance levels that are listed at the top of the tables. And I'm circling levels 4 and 5 because what I recommend to schools is that that's your target. If students perform at a level 3 in the content, they will actually, quote-unquote, pass the test. However, they may not be ready for the next level. So you want to definitely make your target be strong command level 4, if not level 5. And typically at the high school level, I recommend people benchmark their high school honors courses or accelerated courses or advanced courses to that level 5. That's clear readiness for the next level. That's clear readiness for college and high-level careers. The information in levels 2 and 3, though, can be helpful to help us see that partial kind of knowledge that students have. And we're going to look at some examples. The other item of note, on the left-hand side, you'll see these major topical areas in each subclaim. And so we see the first 2 topical areas for Algebra 1 are expressions and interpreting functions. Underneath that, you will see reference to standards from the Common Core. So this is high school algebra, seeing structures in expressions and equations, standard 1-1. And so that's why I recommended you have the Common Core document with you, because it, it might be helpful to look and see exactly what the standard is saying. And as we get into the other subclaim areas, I'll make a few comments about those standards as well. Now, so let's look at this one specifically for Algebra 1. What you notice is, of course, we would expect expressions and interpreting functions to be a major focus area for Algebra 1. Other major focus areas that are not listed on this page, but you'll want to dig into the document and look for, are rate of change, solving algebraically, and solving graphically. Those are the 5 major topical areas for Algebra 1. As I look at my curriculum map then and my end of unit assessments and my unit focus areas, I want to dig in and make sure that I'm addressing those 5 areas very thoroughly. And I want to highlight some things on this table as you look for the level of rigor in your program. And you will see in some parts of these tables that some content remains the same. For instance, at all levels, students will have to write equivalent numerical and polynomial expressions in one variable using addition, subtraction, and multiplication. Now, what you notice here, that's simplifying expressions, that's writing expressions, solving for one variable when you know the other, so on and so forth. But what you see as students move up the performance levels, they start to use different strategies and also solve more complicated problems. So a child who's going to pass the Algebra 1 end of course test, in other words, barely pass, they're going to be able to use factoring. So this tells you that if children cannot factor, they're not going to be able to be successful on the end of course test. Likewise, in order for that strong preparedness for the next level, we're going to include some multi-step problems, and then certainly for those students who are performing at the distinguished commands, they will be able to do this not just with multi-step problems, but multi-step problems in mathematical and contextual situations. This is where you start to see that marriage of the content with the standards for mathematical practice. Again, then, as you look across this table for the second component under expressions, you see there's that interpreting parts of expressions. Identifying components is not enough. And then you notice here for that distinguished command under expressions that they're going to have to evaluate them for accuracy within a context and justify the results. So the highlights I'm putting on here should help you see that as students have higher level exposure to their work with expressions, then they're going to be performing at a higher level. And exhibiting that performance on the end of course test requires doing more things with higher level content. The second one on here is interpreting functions, and I'm just going to highlight a couple things and then we'll move on to geometry. One item of note, and if you are an Algebra 1 teacher, you may want to take a look at the 8th grade performance level descriptors. I actually have a presentation on that. If you want that link, please send me a message. There is a whole lot of function work that gets done in 8th grade that maybe wasn't getting done before we implemented the Common Core. And so you see that the focus at the high school algebra is really on the interpretation of functions. It's not on the definition of functions. And so children need to get to the level of understanding, if certain situations are functions, whether or not it's a function within a context, and so on and so forth. So we're going to also see that if you only get to linear functions for Algebra 1, it's not going to be enough. Kids have to be solidly ready for Algebra 2 or geometry for that matter. You're going to have to dig in and see, you will dig in and see in these performance level descriptors that the kids have to have a solid foundation with quadratics in addition. So as you look at this subclaim A for Algebra 1, you really want to dig into not only these topical areas, but then what does it take for students to perform at level 4?